So, now let us discuss about the completeness property of set of reals. Let R be the set of reals. S be a non-empty subset of R. Then, you can choose any element U in R. Suppose U is in R. If choose this U in such a way that for all S less than or equals U, for all S fallen S. S be a non-empty subset of R, and you can choose a real number U in such a way that S less than or equals U for all S fallen S. Means, you can consider set S equals set 1, 2, 3, 4, etc. up to 10. So surely this is a non-empty subset of R. Okay, set 1, 2, 3, etc. up to 10 being a non-empty subset of R. Suppose 10 is a real number, or 10 falling number, or moreover, suppose here 10 falling number. 10 is a real number, 10 also presents in where? S. Then clearly, any element in this S, which are the elements of S? 1, 2. Here 1 less than 10. Okay, 2 less than 10, etc. 8 less than 10, 9 less than 10, and 10 less than or equals 10. Or 10 equals 10. Clear? Means, all of the element in S less than or equals a particular real number 10, then this 10 is said to be an upper bound of S. It is known as an upper bound of S. Here 10 is an upper bound. So, come to the generalization. If S is a non-empty subset of R, then if you choose a real number U, such that for any S fallen S, that S less than or equals U, then this U is said to be an upper bound of S. Okay. So, if any set of S has an upper bound, then that set of S is said to be bounded above. A set is said to be bounded above if it has an upper bound. A set is said to be bounded above if it has an upper bound. So, according to that argument, here S has an upper bound, 10. So, S is bounded above. Means, here 10 is an upper bound. What is 11? Come to this example. What is 11? 11 is also an upper bound. Why? Because if you choose any element in S, then that element should strictly less than 11. Surely 11 is an upper bound. What about it? 12? 12 is also an upper bound. 11 is an upper bound. 12 is an upper bound. What is 13? 13 is an upper bound. So, any natural number n or any number n which is strictly greater than 10 or greater than or equals 10 is an upper bound. So, how many upper bounds are here? There are infinitely many upper bounds. So, a set has infinitely many upper bounds. Here the S is a finite set. So, this S has infinitely many upper bounds. Okay. So, if a set is bounded above, then it has an upper bound. How many upper bounds are there? There are infinitely many upper bounds, according to this argument. So, what is actually an upper bound? Upper bound means, if S is a non-empty subset of R, then if we choose any element in that R, any real number, then there exists some S fallen S with a S less than or equals U, then this U is said to be an upper bound of S. If a set has an upper bound, that set is said to be bounded. Yep. Okay. Similarly, you can define the lower bounds. So here again consider this S, set 1, 2, 3, 4, etc. Okay. So here again suppose S is a non-empty subset of R. If you choose another element W, that is fallen, yes, sorry, that is fallen now. then this W is said to be, or you can choose this W in such a way that this W less than or equals yes for all S following S. You can choose this W less than or equals yes for all S following yes. Then this W is known as the lower bound of S. It is known as lower bound of S. LB, lower bound. If a set S has a lower bound, then that set is said to be bounded below. If a set has an upper bound, it is bounded above. If a set has a lower bound, that is bounded below. So listen here. Here what is S? S equals set 1, 2, 3, 4, etc. 2. Surely it is a non-empty subset of 1. Then we know that 1 is in S. So you can choose 1. 1 is a real number. It also presents in S here also. Sure. So surely 1 equals 1. 1 less than 2. 1 less than 3. Etc. 1 less than 10. Means all the elements in this S satisfies the condition, or all the elements in S greater than or equals 1. All the elements in S. What is S here? S is set of natural numbers from 1 to 10. So here we can observe that every element in S should greater than or equals 1. Means 1 less than or equals each element in this S. 1 less than or equals each element in this S. So this 1 is known as the lower bound of S. Here 1 is the lower bound of S. So there is another question arises. What about the 0? Surely if you consider 0, 0 is again a real number, then 0 less than 1, 0 less than 2, 0 less than 3, etc. 0 less than 1, etc. 0 less than 10. Means all the elements in this S greater than the 0. So what is 0? 0 is also a lower bound of S. What about the minus 1? Minus 1 is also a lower bound. What is minus 1.2? Minus 1.2 is also a lower bound. Why? Because this minus 1.2 should less than all the elements which are present in S. So surely minus 1.2 is a lower bound. Means here 1 is the lower bound, and every number, every real number, not natural, every real number less than or equals 1 is nothing but the lower bound of this S. Okay. So how many lower bounds are there? There are infinitely many lower bounds. So since S has a lower bound 1, so S is bounded below. So if S set is said to be bounded above, if it has an upper bound, S set is said to be bounded below if it has a lower bound. So clearly this S has both upper bound and lower bound. Means S is both bounded above and bounded below. If a set is both bounded above and below, that set is said to be a bounded set. So this is S is bounded. Why? Because S is bounded above as well as S is bounded below. Because S has an upper bound and S has a lower bound, since S is bounded. So a set of real number, subset of real number is said to be bounded if it is both bounded above and below. More precisely, it has an upper bound as well as lower bound. Okay. So this is the crucial definitions. What is an upper bound and what is a lower bound? S is an upper bound. There exists a real number U with every element in that set has set less than or equals that real number. If it is bounded below, then there exists a real number in such a way that every element in that set should greater than or equals that a real number which is you choose. Okay, so this is the upper bound and lower bound of a set. Clear? Then a set is bounded. A set is bounded means it is both bounded above and below. Clear? So you can consider another set. S equals set of 1, 1 by 2, 1 by 3, 1 by 4. So, which is up? Is it bounded? Our question is this one. State whether S is bounded or not. So, in order to check a set is bounded or not, first we have to check that the set is set has an upper bound, is the set has an upper bound or lower bound, and as well as a lower bound. Can you say that S has a lower bound or S has an upper bound? How to check? Means, what about consider this element 1? Consider this element 1. So, suppose 1 is a number. 1 is a real number. You know that 1 is a real number. 1. We choose consider every element. What is the peculiarity of elements in S? That element has a tendency to reach or 1 by 2, 1 by 3, 1 by 4, 1 by, here actually it is 1 by 1, 1 by 5, 1 by 2, etc. 1 by n. So when n goes to infinity, this element has a tendency to goes 0. Okay. So 1 is a real number. Then we can say that every element in this set S, every element, suppose S is this is S equals 1 by n, where n equals 1, 2, 3, 1, 2, 3, 4, 5, etc. Okay. So every element in S that should less than or equals 1. Means every element in S less than or equals 1. So 1 is a real number. Every element in S less than or equals U is an upper bound. Every element in S less than or equals 1, so 1 is an upper bound of S. What about 1.5? Oh, sorry, 1.1. Sure, 1.1 is an upper bound. What is 1.2? Sure, it is an upper bound. So every real number greater than or equals 1 is an upper bound. Means S has an upper bound. So S is bounded. Yes, bounded. Okay. Now, this S consists of non-negative numbers. Non-negative. There is no negative number. What about 0? 0 is a real number. 0 is a real number. 0 is a real number. Then we can choose any element in this S. Then we can say that the 0 less than or equals S fall in S. 0 is the least element. So what is 0? Every element in S greater than or equals this 0 means 0 less than or equals S for all S of all in S. Then what is 0? According to our definition, 0 is a lower bound. 0 is a lower bound. What is minus 1? Lower bound. Minus 2, lower bound. Why? Because all the element in S should be greater than or equals the S stated elements. Okay. So 0 is a lower bound. Since S has a lower bound, so S is bounded below. Okay. Since S is bounded above and S is bounded below, so surely it gives S is bounded. So this is the definition of a boundedness of a set. If it is bounded below and bounded, a set S is said to be bounded above. If it has an upper bound, if it is said to be bounded below, then it has a lower bound. A set is said to be bounded if it has both upper and lower bounds. Okay. And a set has finite. If a set is bounded above, it has infinitely many upper bounds. A set has a lower bound, then it has infinitely many lower bounds. How many upper bounds are there? Infinitely many upper bounds. If a set is bounded above, how many upper bounds are there? Infinitely many. If a set is bounded below, how many lower bounds are there? Infinitely many. Okay, thank you.